Okay, let's dive in. We're taking a look today at some, well, truly audacious goals,
Hmm.
specifically centered around making humanity a multiplanetary species.
Right. Big stuff.
Yeah, and this deep dive is based on insights from excerpts of a recent video transcript. It outlines SpaceX's progress and, their future predictions for Mars.
And the place that really brings all of this into sharp focus is Starbase down in South Texas. It's kind of the physical hub where this whole vision is starting to, well, take shape.
Absolutely. So, our mission here in this deep dive is to unpack the key facts, the figures, the technological hurdles, and these really ambitious timelines presented in the source material.
Yeah, to really get a handle on the scale and the purpose behind it all.
Exactly. It's a story that often feels like it belongs in, a sci-fi novel.
For sure.
But the source makes a pretty compelling case for it becoming reality, maybe sooner than a lot of people might think.
It's definitely a complex picture. You've got this massive infrastructure build-out, groundbreaking technology, and this really long-term vision for, well, the survival of civilization itself.
So let's start right there, at Starbase. The source describes it in a way that immediately grabs your attention. The first new city built in America in decades.
That description is striking, isn't it?
Yeah,
Especially when you think about where it came from. Essentially just a sandbar, nothing there.
right.
And in just, what, 5 or 6 years, the team there has put up, well, basically a small city, plus 2 gigantic launch pads and this enormous rocket factory.
And what I found particularly interesting from the source is how accessible it all is.
Hmm.
It's not some, secret government base hidden away. It's right there on a public highway in South Texas.
That's a really unique point the source highlights, yeah. You could literally just drive down a public road and see these massive structures.
See the rock.
See the rocket itself, the factory up close. The source frames it as, like, the first time in history that space development on this kind of scale is publicly viewable like this.
Gives you a real tangible sense of what's going on.
It really does.
Thinking about that scale, it naturally leads us to the vehicle they're building there, Starship.
Right.
The source gives us some pretty incredible numbers on its production.
Yeah, right now production is roughly 1 ship every 2 or 3 weeks. Something like that. Though the pace varies a bit, depending on design upgrades and stuff.
But that's just the starting point.
Right. Just the beginning.
The ambition is, well, it's on a completely different level. The future goal, according to the source, is to produce 1,000 Starships per year.
1,000.
Yeah.
Which works out to 3 ships per day.
3 a day?
When you hear that number, you kind of have to pause.
Yeah.
And to achieve that, the source mentions they're building this thing they call a gigabay in Texas.
A gigabit.
Yeah, basically a colossal assembly building, described as potentially one of the biggest structures in the world by some measures,
Wow.
specifically for that 1,000-ship-a-year goal. And they're planning another one over in Florida, too.
Okay, let's try and put that in perspective. Each Starship is enormous, bigger than a Boeing 747 or an Airbus A380.
Exactly. Huge. So the goal isn't just building rockets like we've thought about them before. It's aiming to build as many of these giant starships every year as, like, Boeing and Airbus combined make commercial airplanes.
That comparison really hits home.
Yeah, the source uses it to argue that while these targets are, totally unprecedented for spaceflight,
You're right.
they are achievable by human industry standards. They point out that, industries like car manufacturing already handle vastly more complex manufacturing tonnage.
So it's ambitious for space, but maybe not impossible for industry.
That seems to be the argument, yeah.
The source also briefly mentions the Starlink V3 satellites here. They're described as roughly the size of a Boeing 737.
Yeah, huge satellites. And the production targets there are also massive, 5,000 to 10,000 per year.
It's another piece of this large-scale manufacturing puzzle.
It really reinforces that this isn't just about one rocket program. It's a whole ecosystem, technology, production scaling, the whole thing.
Okay, so we have this incredible production machine being built at Starbase. But what's the ultimate driving force? What's the why behind all this?
The source makes it crystal clear. The grand vision is establishing a self-sustaining civilization on Mars.
Self-sustaining.
That's the key. Everything happening at Starbase, every technical challenge they face, it's all measured against the timeline to achieving that goal.
And self-sustaining is a critical term here. What does the source really mean by that?
It means Mars needs to get to a point where it can keep going, keep growing, even if the supply ships from Earth just stopped for whatever reason.
So, completely independent.
Totally. It needs everything required for survival and growth. The source even gets down to needing the equivalent of, like, vitamin C production on Mars. It has to
Right.
function as a standalone civilization.
And why is achieving that self-sustaining status so important? What's the driver?
Well, this is where the vision gets even bigger than just space exploration. It ties into civilizational resilience.
Resilience.
Yeah, having two strong, self-sustaining planets, Earth and Mars, dramatically increases the long-term survival odds for humanity, for civilization. The source suggests a multi-planet civilization could potentially last, 10 times longer, maybe much, much longer than one stuck on a single planet.
Because a single point of failure is just too risky.
Precisely. It's about protection against those unpredictable, catastrophic events.
Like what?
Well, the source mentions both human-caused possibilities, like, heaven forbid, conflicts on the scale of a world war,
Right.
and also natural threats, big meteor impacts, supervolcanoes, that kind of thing. If something wipes out a single-planet civilization, that could be it for conscious life as we know it.
But with a backup.
With a self-sustaining backup, civilization persists. It has a chance to continue.
And the ambition, according to the source, doesn't just stop at Mars, does it?
No, not at all. The vision ultimately stretches out further, exploring and maybe using resources in the asteroid belt, reaching the moons of Jupiter,
Wow.
and eventually even aiming for other star systems. It's framed as, turning these fundamental science fiction ideas into actual reality.
Okay, so how do you even begin to get there? What are the absolute essential technological pillars needed to make this vision of low-cost, high-volume transport to Mars actually happen?
The source really hammers home one key technology: rapidly reusable, reliable rockets.
Or RRRR.
Catchy.
Yeah.
But getting the cost per ton to Mars way down is fundamental. And that absolutely requires rockets you can use over and over again really quickly.
And the method for achieving that reusability for the giant super heavy booster, it sounds almost absurd, catching it out of the air with giant chopsticks.
It does sound like something from a cartoon, doesn't it?
Totally.
But the source points out they've actually done it.
Yeah.
Successfully.
Oh.
Multiple times now.
Which is amazing.
It's never been done before, catching the largest flying object ever made as it's coming down. And the critical reason for using those tower arms, the chopsticks, it isn't just for show. It's about speed.
Speed? How so?
It lets them immediately place the booster right back onto the launch mount so they can refuel it quickly and potentially fly it again within just an hour or two.
That kind of turnaround for a booster that size is just unheard of.
Completely game-changing if they can make it routine.
So what's the next big step they're working on for reusability?
Catching the ship itself, the upper stage.
Okay.
That hasn't been demonstrated yet. But the hope mentioned in the source is maybe later this year, perhaps in the next 2 or 3 months, they said.
And the goal there is the same, rapid reuse.
Exactly. The idea is that the ship, after orbiting Earth, could also be caught and turned around for potentially multiple reuses per day.
Another piece of the puzzle the source highlights is the engine, the Raptor 3.
Oh, yeah.
It's described with some pretty strong terms. Awesome, revolutionary, even alien technology.
The source definitely expresses a lot of enthusiasm for this engine. And, well, the technical leaps it represents seem pretty significant.
Like what?
Well, one key feature is that it doesn't need a basic heat shield on the engine itself, down at the bottom of the booster.
No heat shield. How does that work?
It saves mass, which is huge, but it also apparently improves reliability. Because if there's a small fuel leak, it can just burn off safely in the plasma during ascent instead of being contained and causing problems.
Interesting.
And it achieves really high efficiency and reliability through a simplified design, fewer parts, integrated components, which in turn massively increases the payload the rocket can carry. The source notes that even other rocket engineers were apparently surprised by how simple it looked, thinking it wasn't finished.
Huh. So we've got the reusable rocket, the advanced engine. But what about getting enough fuel all the way to Mars?
Right, that brings up orbital propellant transfer. It's absolutely essential for Mars missions.
Why is that?
Because the ship just can't carry enough fuel launching from Earth's surface to get all the way to Mars, land, and potentially return. There's just not enough room after accounting for payload.
So like aerial refueling for airplanes.
Exactly the analogy they use.
Yeah.
But done in orbit between two starships. One ship basically acts as a tanker, a fuel depot,
Okay.
transferring propellant, mostly liquid oxygen actually, about 80% by mass to the Mars-bound ship.
So a Starship can launch, packed with cargo, get to orbit, and then get its tanks filled up before heading off to deep space.
That's the plan. It's a critical capability for any mission beyond Earth orbit, really, to Mars, the moon. The source hopes they can demonstrate this orbital refueling sometime next year.
Okay, but the source also calls out one of the most difficult technical challenges they face, the reusable heat shield for the Starship itself.
Yeah, this one sounds really tough.
Described as extraordinarily difficult and something never truly achieved before for a vehicle returning from orbit, not in a rapidly reusable way.
This really highlights a core engineering problem, doesn't it?
Yeah.
Re-entry is brutal. Extreme heat, extreme pressure.
Right.
Doing that reliably, repeatedly, requires these advanced materials, ceramics, glass, composites, that can take that punishment without eroding or cracking or falling off, and then be ready to go again quickly.
Unlike the shuttle tiles, which needed tons of work.
Exactly. The source contrasts it with the space shuttle's heat shield, which needed months of careful inspection and refurbishment between flights. The goal here is much faster turnaround.
And the source specifically mentions that going to Mars makes this heat shield problem even harder.
It does, because of the atmosphere. Mars' atmosphere is mostly CO2, carbon dioxide.
And that's worse.
Apparently so.
Yeah.
When it hits the extreme heat of re-entry and turns into plasma, it creates significantly more free oxygen compared to Earth's nitrogen-oxygen atmosphere at those temperatures.
More oxygen, meaning more burning.
Basically, yeah. More potential for oxidation. That extra oxygen is highly reactive and wants to essentially burn or corrode the heat shield material. It's a harsher chemical environment.
So they have to test specifically for that Martian environment.
Rigorously. The source explains they test heat shield materials in a pure CO2 plasma environment. The key goal, though, is to develop a heat shield structure and material that works for both Earth and Mars re-entry.
Why both?
So they can perform hundreds, maybe thousands, of test re-entries here on Earth to gain confidence, iterate the design, make sure it's reliable, before they ever have to trust it for a Mars landing.
Makes sense. Lots of practice.
Yeah. The source acknowledges this tech is tough, will take a few years to really perfect, but they seem confident it's achievable.
Let's shift focus slightly to the evolution of the vehicle itself. The source talks about the next generation Starships, specifically version 3. What are the key changes there?
Okay, so V3, they're a bit taller, around 72 meters for the ship compared to the current ones, which are about 69 meters.
Okay, a little stretch.
Yeah, and there's an improved interstage, that bit connecting the booster and the ship. It's designed for hot staging.
Hot staging? What's that?
That's where the ship's engines actually ignite, while the booster's engines are still firing, just before separation.
Whoa.
Yeah, it gives an extra performance kick. The flames vent out through struts in that interstage section. And with V3, those struts are designed to return with the booster, rather than being thrown away like on some earlier tests.
More reusability.
Exactly. Also, propellant capacity is increasing significantly. They're aiming for around 3,700 to 4,000 tons for the booster and over 5,550 tons for the ship, long term.
Are there visual differences we might notice?
Yeah, a couple things. The bottom of the V3 booster looks kind of naked, is how the source put it.
Naked?
Because those Raptor 3 engines don't need that base heat shield anymore. And the ship's heat shield itself is meant to be sleeker, smoother compared to some of the earlier prototypes you might have seen.
Okay.
And the source even speculates about future versions potentially having more engines, maybe getting up to 42 engines on the full stack eventually.
42. That sounds familiar.
Right. The source notes, it was coincidentally the number predicted by Douglas Adams in The Hitchhiker's Guide to the Galaxy.
Huh. That's fun.
Little nod.
So the source seems to view this version 3 as a real turning point then.
They definitely do. The belief expressed is that with the Raptor 3 engine and the Starship Booster V3 designs, all the fundamental technological puzzle pieces needed for making life multiplanetary.
Like the rapid reusability, the orbital refueling, the durable heat shield.
Exactly. All those key ingredients should now be achievable. The target date mentioned for the first Starship V3 launch is the end of this year.
So this version, V3, is considered capable of actually making the whole Mars vision possible.
Yes, the source states V3 is capable of it. Future versions will likely focus more on increasing efficiency, driving down cost even further, much like how we saw the Falcon 9 rocket evolve over many iterations.
Refining the process.
Precisely. Because ultimately the goal isn't just the technical capability. It's reducing the cost per person, the cost per ton, to a point where, as the source puts it, anyone who wants to participate in building this new Martian civilization can potentially do so. It's framed as the best adventure.
Okay, so with all this technology hopefully coming together with V3, what's the sort of realistic timeline for actually getting something to Mars?
Well, the physics dictates the schedule there, mostly. Mars transfer windows, the times when the planets are aligned for the most efficient journey, they open up roughly every 26 months.
Every 2 years or so, and when is the next window?
According to the source, the next good opportunity is at the end of next year. So about 18 months away from now, specifically around November or December of next year.
And what's the plan or the hope for that window?
The source states they will attempt the first uncrewed Starship mission to Mars then. If. It's a big if.
Mm.
If that orbital refilling capability is fully figured out and reliable in time, they put the current odds for actually making that window at around 50-50.
Okay, so fingers crossed on the refueling tech. If it launches then, when would it arrive?
It would get there in 2027, technically. Takes about 6-9 months to travel.
And what would those first uncrewed missions carry? Just test equipment?
No, the plan mentioned is for them to carry the Optimus robot.
The humanoid robot.
That's the one. The source sees Optimus playing a crucial role early on, exploring, setting things up, preparing the way for humans. The prospect of seeing Optimus walking around on Mars in 2027 is described as epic.
That would be pretty amazing. And when might humans follow?
Well, assuming those initial robotic landings and the prep work go well, humans would likely be sent on the next Mars mission opportunity. So 2 years after that first uncrewed landing.
So maybe 2029 arrival.
That's the rough timeline suggested. Though the source also suggests they might want to send maybe 2 successful Optimus missions first, just for added safety and preparation before putting people on a ship. So could slip a bit. And it's worth remembering, that achieving this capability for Mars also unlocks other really significant steps closer to home, like establishing a proper moon base.
Right.
The source playfully calls it Moon Base Alpha and suggests it could support a massive science station there.
And the sheer payload capability is just wild.
Yeah, with full reusability, Starship V3 is designed to send 200 tons to low Earth orbit.
200 tons?
The source highlights that this is twice the payload capability of the old Saturn V moon rocket, which was previously the biggest ever, and that was fully expendable.
Wow.
And if Starship were flown expendable, just throwing it away, it could theoretically send maybe around 400 tons to orbit. It just underscores the massive scale of this vehicle, which is what you need for that Mars City vision.
Let's try and visualize that based on the source material. What might that first city or outpost on Mars actually look like?
Well, it's going to need a tremendous amount of solar power, that's for sure.
Makes sense.
Initially, people will definitely need Mars suits to go outside on the surface. They'll likely live inside structures, habitats, maybe something like glass domes eventually, until much further down the line when something like terraforming might become possible, if ever.
And the sheer volume of stuff needed to build a self-sustaining civilization. The source gives a number that's almost hard to comprehend.
It really is. The estimate mentioned for the total mass you'd need to land on the surface of Mars to reach that point of self-sustainability is over 1 million tons.
1 million tons?
Yeah, and that could potentially mean transferring a megaton per transfer window, 1 million tons every 2 years. And the source even caveats that the total needed might ultimately be 10 million or even 100 million tons. We just don't know for sure yet.
1 million tons per window. I mean, that conjures an image of a lot of ships arriving all at once.
Absolutely. The source paints this picture of the future where during those transfer windows, you'd have thousands of ships.
Thousands?
Maybe 1,000, 2,000, perhaps even more, gathering in Earth orbit, waiting for the signal to depart for Mars. They envisioned something like a Battlestar Galactica field of spacecraft.
That's quite a visual.
And then on the Mars side, you'd need the infrastructure to handle all those arrivals. Hundreds of launch and landing pads, or some way to get ships off the pads extremely quickly after landing.
Does the source mention a specific potential location for where they might aim to build that first city?
Yes. The leading candidate that's discussed is a region called Arcadia Planitia.
Arcadia. Why there?
Seems it's favored partly because it's relatively flat, which is good for landing. It's thought to have abundant subsurface water ice, which is critical. And it's not right at the pole, so temperatures are a bit more moderate.
Makes sense.
The source also adds a little personal touch, mentioning that Arcadia also happens to be the name of his daughter.
Ah, okay. How will communication work, with Earth being so incredibly far away?
They plan to use a version of Starlink, their satellite internet system, to provide connectivity on Mars itself and presumably back to Earth.
But the delay.
Right. The speed of light delay is unavoidable. Physics is physics. At its closest, Mars is about 3.5 light minutes away from Earth.
3.5 minutes each way.
Yeah, and at its furthest, it's over 22 minutes each way. So real-time conversations like this, impossible.
Ooh.
But Starlink is intended to provide high-bandwidth data transfer despite that lag, sending messages, videos, data packets.
Okay. And beyond all the technical and logistical hurdles, the source touches on something pretty profound, the potential for a new kind of society on Mars.
This is a really fascinating angle they bring up. The idea is that Mars offers this unique, maybe once in many lifetimes, opportunity for the early Martians to fundamentally rethink how they want civilization to be.
A blank slate, almost.
Kind of. It's framed as a chance to recompile on civilization, is the phrase used, with the freedom to potentially redefine core aspects like government, laws, social rules from the ground up without the baggage of Earth's history.
That's a powerful idea, a chance for innovation in how we organize ourselves.
Huge potential there, yeah.
Now, before we wrap up, the source makes a very, very direct connection between this whole ambitious Mars vision and their Starlink internet service back here on Earth.
Yes, they are explicitly linked. According to the source material, the revenue generated by the Starlink internet service is the primary funding mechanism for the entire Mars endeavor.
So Starlink is paying the bills for Starship and Mars.
That's what the source states, yes. It's what's making this massive long-term project financially feasible, according to them.
And there's even a direct message of gratitude in there for Starlink users.
There is. The source expresses sincere thanks to Starlink customers, essentially saying that they are the ones helping to fund the securing of humanity's future and making humanity a truly space-bearing species.
Wow. It really ties the whole narrative together, doesn't it? From the very beginning, starting Starbase on basically a sandbar, through all these incredibly difficult technical challenges, the mind-boggling production scale needed, all the way to this immense vision of building a city on another planet and even touching on the business model intended to actually pay for it all.
And reinforcing that core goal, make Mars self-sustaining and do it as quickly as possible, with the ultimate aim, as stated, of enabling anyone who really desires to participate in building this new civilization, this new branch of humanity, to potentially do so. It's presented as potentially humanity's best adventure.
So just reflecting on everything the source material lays out, I mean, the sheer, almost unbelievable scale of the Starship program, the difficulty of these cutting-edge technologies like the reusable heat shields, the orbital refueling, and the incredible ambition of landing 1 million tons of stuff on Mars to build a self-sustaining city, it really makes you think, doesn't it, about the kind of future that's being actively worked on right now. How wild would it be to actually participate in that adventure someday? Or, to see friends or maybe even family eventually make that journey.
It truly is mind-boggling when you try to grasp the scale and the ambition involved. And if we take seriously that idea the source raises about a potential recompile on civilization on Mars. Well, it sparks a really interesting question for all of us, doesn't it? If you were starting society completely fresh, on a new world, totally unburdened by Earth's long history and existing structures, what fundamental aspects, maybe government, economics, social rules, what might you choose to design completely differently, given that blank slate?